Hi, Mr. Tokuhiro.
Hello, hello.
Hello. My name is Fatma, and I am working as a secretary at Student Guild of the Thorium Network. And I want to ask some question. What do nuclear energy experts do? Please, can you explain for us?
What do experts do?
Yeah.
Oh, we do many things, but we design next generation 4 systems, or we look at the safety issues of current reactors and reactors that are in construction. So we are always looking for continuous improvement or continuous safety improvement, and looking at three questions, right? What can happen, or how often can it happen? How does it happen? And what are the consequences of some accident happening? Yeah, so we ask these questions and we do the engineering and design and safety analysis for that. Many times now in nuclear engineering requires computer programming and work analysis. And now with unknown factors, we are now with younger engineers, we see applications of virtual reality and augmented reality. We see new applications of artificial intelligence and machine learning now. So that will be the next, not old people, not an old person like me, but next generation young people.
These are really complicated questions to answer.
Yeah. Good question. Yeah.
Okay, and next question. In one of your interviews, Titans of the Nuclear interviews, I listened your interview, and you said nuclear reactors are challenging, and that's why you choose to work nuclear area. What is the most complex and challenging thing in the nuclear area or nuclear physics, reactor physics?
Yeah, for me, the most interesting and challenging is that you have to know many things and be able to not consider, there's no one small area where you find the solution. You may find the solution, but usually nuclear reactor, nuclear plant, power plant is many different things. So if you find a solution for one area, it may impact other things. So you have to look at many different things, and you have to integrate, and that's challenging for me. Yeah.
Especially neutrons' behavior. It's so hard to control.
Yeah, so that is part of when I teach students. How do you design the reactor? Is you design from the reactor core, and then you go out of the reactor. So the vessel, the auxiliary systems, and eventually you have, maybe you have to sometimes look at the nearby city, how they're going to evacuate in case of an accident. Yeah, so you have to look at many different things, and that's always very challenging.
Yes, thank you. The next question I want to ask is, what are the most common safety design features for generation 4 that can be used also generation 3 and generation 2 reactor types?
So yeah, so we have learned from generation 2, 3 plus that human beings, two things about human beings in human factors. Human beings are unreliable and unpredictable. So when you apply that to safety systems, you want to design the reactor so that the human being is not a factor. So generation 4 and small modular reactors, the design is such that it will cool by itself without human intervention, because human being is unpredictable and unreliable, can make mistakes under pressure or under accident condition. So you have to design the reactor so that after shutdown, the decay heat, the remaining heat can be removed without human intervention. Yeah.
Yeah. So there will be no human mistakes.
Yes, exactly.
Okay. The next question is, what is the biggest problem about safety that must be redesigned immediately now? So we have, for example, we have now generation 2 and generation 3 BWRs all over the world. So what is the biggest safety problem about that may be redesigned?
Yeah, I think that my opinion is that the reactor is designed so that it can shut down. That's okay. So even an earthquake, it can shut down. Like in Fukushima Daiichi,
yes,
the reactors did shut down at the earthquake.
Yes.
To remove the what's decay heat or the heat that's remaining, using pumps, for example, is for many hours, more than 72 hours. First 24 hours and then 48 hours and 72 hours, and maybe up to 2 weeks. That has to be guaranteed. So that change needs to be made at all the plants. I think thank you to the IAEA, that cooling after shutdown is mostly we can do that. It's possible, but we have to make sure, even if you have a terrible earthquake and everything else is destroyed, nuclear plant workers are very dedicated, and they have to make sure that the pump is working. With small modular reactors, it's not necessary to have a pump, but with large reactors, you have to have a pump, and you have to have a source of water, and you have to maintain. You cannot have a leak. You have to maintain the coolant to take away the heat from the reactor core. Yeah. So the safety problem is to prevent the meltdown of the core.
Yes.
And that you can, if you maintain the cooling, then you can maintain the core.
So that's why natural convection is needed for generation 4 reactors.
Yeah, generation 4 reactors and small modular reactors. Yes, some designs have no pumps. Yeah. Okay. Because a pump can, fail to start, or can start but then fail, stop working. And a pump is usually electrical, mechanical.
Yeah.
So you can push the electrical switch, and this doesn't start sometimes.
Yes.
So there are three or four possibilities that it does not operate as expected.
Yes.
Hello, I am Veli. I am student of nuclear engineer, and I am member of Student Guild in Thorium Network.
Okay.
What is your thinking? When do you think the first generation 4 reactor will be built, and where it be built, and which design will be built?
So good questions. I think by 2030 or 2035, 2030, some generation 4 reactor will be built. Probably, maybe generation 4 large reactor, maybe generation 2035, but small modular reactor before that. It depends on the country. I think you have a reactor in construction in Turkey.
Yes.
And
yes.
Yes.
There's
yeah. So China and Russia have their own designs, and they are being constructed. can you call them? It's difficult to call them Generation 4, but it is an improved design of the VVER
Yes.
design. Yes, they're in El Dabaa in Egypt. They build more reactors, right? Also,
Yes.
and small. So, and China's building different kinds of reactors and operating them. I just saw that in Pakistan they are operating, or maybe it was in Pakistan or India. They just started. They connected the new plant to the grid. Yeah. So, I think the answer is certainly by 2035, a small modular or large reactor, maybe generation 4, hopefully will be built by Russia or by China. In the West, it very much depends on the loan and the investment, right?
Exactly.
So by 2030, I think in North America, for example, there will be a small modular reactor before 2035. So each country is a little bit different. Yeah, but we need more nuclear power.
Yes,
it's for sure. Yes.
Okay.
The next question is, what are your thoughts about thorium molten salt reactors?
Yeah, so thorium molten salt reactors are very interesting and require more engineering.
Yeah.
So at least the next 3 to 5 years, we really need much more engineering to finish the design and to get the regulatory approval of this design. So, so since my background is from the U.S., I'm familiar with the U.S. Nuclear Regulatory Commission, and they mainly ask about the safety questions, about design basis accidents and beyond design basis accidents, and how your design is can withstand the accident conditions or be completely independent of the accident conditions, because the design is so simple. For example, if you don't have a pump in natural convection cooled, then it's a better design than with a pump, because you can have a design basis accident as long as the heat is removed from the core. Yeah, so the molten salt is actually a very interesting design. And thorium is also a different type of fuel. So with each new idea, it's very similar to a restaurant or automobile. You have to have customers. You have to have, or in a restaurant, you have to have good food, and people have to come and eat, right? If you have an automobile, you have to make a model that's popular, and people have to trust the safety, and they have to buy. So with a nuclear reactor, yeah, it has the safety case with the new design, the thorium molten salt design. The design has to be finished and have to convince the regulator that it's a good design and it can be constructed.
I want to ask about Canada now. I really wonder what they think about molten salts. Well, they have their own designs, can-dos, but what they think about molten salts?
Yeah, the molten salt reactor, there's a Canadian-US company called Terrestrial Energy, and they have a small modular reactor design that's molten salt, not thorium, uranium, but uranium fuel, but molten salt. So again, as I said, the design has to be finished, and so that in thinking that the regulator is going to approve the design for construction.
Yeah. Okay.
Yeah. So in Canada, because we have this Canadian Nuclear Safety Commission, and just south is the U.S. Nuclear Regulatory Commission, the design has to be finished and it has to be approved. Yeah. So it's a situation very different from from Russia or China, because they have their own national designs, right? This is a commercial. The terrestrial energy design is uranium fueled, molten salt cooled, and fueled. And there are many interesting engineering design elements, but the safety in design has to be guaranteed.
I think China have one MSR, right?
Small
reactor, but
2 megawatts.
2 megawatts, yes.
Research
Yeah.
Research.
Yes.
I have also one question for you. You are an expert on nuclear safety, and you are really know the nuclear safety design. Do you think passive safety system design for molten salt reactors are sufficient? Are there any other passive system design for these reactors? Can you please?
Yeah, so the molten salt reactor concept came from late 1950s and early 1960s.
A bit old.
And yeah, and the design that's followed, that's modernized design is the Oak Ridge molten salt reactor experiment, MSRE. Okay, so they operated a research reactor or demonstration reactor for a few years. So now 50 years later, we update the design, right? Because 50 years ago, there was no computer-aided design. We didn't have the computing power as we have today. So I think the concepts are still good. The safety case is convincing. But actually, well, the AirMess reactor demonstration, the research reactor built by Kairos and the U.S. Department of Energy will demonstrate some of those safety features. So the first step in building the reactor is if possible, if you have the money and the engineer, Kairos has the engineers.
Yes.
You have to make a demonstration or research reactor, and to show that it's very safe, right? So that the shutdown system, especially shutdown system, is the molten salt and the fuel, it goes into, instead of the core, it drops into a tank.
Yes.
And yeah. So it looks like a. So that's by gravity, right? It's driven by gravity. So no human error is possible. So it looks like a very, that's certainly possible.
And it's really safe.
Yeah, it looks like a safe design. Yes.
I want to ask you one more question about about thorium molten salt reactors. What can students do?
Oh, so that's a very good question. So now in the last 5 years, it's been, we had social media for more than 5 years, but in the last 5 years, I think it's very important for the students to find friends all over the world, and to be worried about climate change.
Yes.
And low carbon or net zero carbon, and we need to reach a net zero carbon economy as quickly as possible, even before 2050.
Really?
So
close?
I think we have to, with each 5 years, it becomes more and more difficult if we don't reach. So we have to make progress by 2030, and if not, then the next is 2035, and 2040, and 2045, and 2050. So by 2050, we have to have low carbon or net zero carbon economy, and that's really difficult. So if we don't make progress by 2030, then it's next is 2035. It becomes more and more difficult, right? If you wait for the final exam, to study. You have to study each day, not at the very end.
You cannot be success. No, you cannot.
Yeah, it's very difficult to have exams and study at the very last minute and to do well. So you have the power of social media, and you have to ask many questions. And I think what students can do is ask the old people like me many questions about safety and the design, and we have to change and put pressure on the regulatory. The regulator has to approve, has to be very open in their process, right? Because now we have to assume with the Google Translator or people who speak English. English is, for engineers, English is becoming the global language, and social media, Twitch,
that we have
with LinkedIn, and so we have many experts from many countries, and we only have about 450 nuclear power plants in the world. We need 10 times that. We need 4,500, because how many automobiles, right, do we have in the world? More than 10 billion.
Yes.
Yeah, lots of them. So we need much more nuclear power now, because this is something we know how to do. So it's not the ultimate solution for climate change, but it's a solution that we have now. We should use nuclear power now because we know how to make nuclear power plants and to operate them, right? So young people can become involved through social media and ask good questions and to make the change, because older people like myself, we want to change, but we are not. I'm an engineer. I'm not an expert on finance and investments, right? Nuclear power plants, even small modular reactors, cost money. So, and they will become cheaper as you make more and more reactors. So we need more nuclear power now. I like wind and solar, also and hydrogen as well. We need a diverse energy portfolio, and we need to convince people that we need everything now, right? Or we have to use less energy. So
I think it's not possible.
It's not possible, right?
Yes.
So so you have to. I think young people have the power to say, okay, it's not possible to use less energy, right? So we need nuclear power. It may be risky, it may be dangerous, you may fear, but risk is a spectrum, right? If you think the benefit is greater than the risk, then you will do it, right? So if you had the airplane ticket to come to see me in Argentina,
yes,
there's a risk, right, in taking a flight from Turkey to Argentina, but but the benefit is much larger than the risk.
I will totally do it, by the way.
Yeah. So that benefit may be 100 times or 1,000 times bigger than the risk. So same thing with nuclear power. You have to make the benefit much larger than the risk.
Yes.
Yeah. So, but people are usually afraid if they don't understand the risk. So they think that the risk is very big and the benefit is not so big.
Not just with nuclear or not just with wind and solar. It's a combination, right?
Yes.
We make it happen.
Yeah. So you make the personal choice. What is the benefit? What is the risk? And I never think to not take an airplane, because the benefit is always much bigger for me.
Yes.
So, okay. So, and I think I of course, as an engineer, I would rather fly a Boeing 747 because it has 4 engines, not 2 engines.
Yes.
So it's hard to convince an engineer if you only have 2 engines, the airplane can still fly with only 1 engine.
Yeah.
Right. But so if you have 4, I would rather have 4 engines. But okay, now most Boeing and Airbus planes are only 2 engines. Okay, I still the benefit is still greater than the risk. Yeah.
Yeah.
Of an accident, right?
Yeah, good answer. Thank you.
Yeah.
And the next question is a bit personal. I really wonder your answer. How did you decide to join the Thorium network? What was the most thing that impressed you about Thorium network?
Well, I think I came in contact with one of the founders, Jeremiah.
Yeah, he said
Josey.
hello to you, by the way.
Oh, okay. Yeah, so hello to him also. And I thought the thorium reactor is an interesting alternative to uranium. And there were it's a network, right?
Yes.
So it includes many people, including myself. I have just a small part. I'm interested mostly in the engineering and the safety and design, and getting the regulatory approval. So that's why I joined, and I noticed it had people. Jeremiah is very talented in gathering people together.
Yeah, he is.
So yeah, so from South Africa, from Korea, from Turkey, from Japan, he has many people, and the network is a new way to design a reactor. So this is an interesting challenge.
Yes, exactly.
And one I support. Yes.
That's impressed me too. Yes. Okay, our last question. Can you give me 3 names that I can interview them? And also 3 names that want to support our student guild financially. And are you one of them?
Oh, okay. Yeah, I can try to support you. I mean I support the young generation.
Yes.
Nuclear.
Yeah.
So I have been to 2 or 3 of their conferences. If you have a chance to go to the young generation, the International Youth and Nuclear Congress, IYNC. I don't know where the next one is, but that's they had one in Australia, right?
Yes.
It was it's a terrific. Yeah. So yeah, I can support the Thorium group, and then 3 other people. Yeah, there are many names. Who do you want to talk to?
Maybe expert on can-dos, and we can discuss which is better, can-do design or MSRs.
Okay. Well, Professor Glenn Harville, Harvel, Harville, Glenn, his first name, knows can-do systems very well.
Okay.
You may want to talk to Professor Filippo Genco, my colleague, GENCO. He's from my same university, but he has a lot of knowledge about renewables and fusion. And he has worked in Dubai, I think, and he has worked in Chile, Santiago. And now he's with Canadian University. Filip Bojenko is another one. Yeah, did you talk to the Director General of the World Nuclear Association?
No, not yet.
Okay, so I might recommend Dr. Sama Bilbao y Leon.
Yes, I know her. Yes, she's perfect.
Yeah, so I know her because I know her from maybe 20 years now. So she's she's another person. Well, actually, there's one more. So one more. You know, we have we should invite 2 males and 2 females. So Dr. Sama Bilbao. Maybe one of my former PhD students, if you want to talk to her.
Okay.
Her name is Leslie Kirby, Kerby, Kirby. Okay. Leslie, I can give you you send me an email and I can send you the. So she's a professor of computer science and nuclear engineering. Yeah, maybe she's a good one. I can also recommend. Yeah, let me see. Well, you may want to talk to a younger person. One of my colleagues, younger colleagues, Mario Gomez Fernandez. Gomez, Gomez, Fernandez, Fernandez.
It sounds familiar. Maybe I saw on LinkedIn.
Yeah, we wrote some papers together on applications of AI and machine learning for nuclear applications. He works at NuScale Power right now. So yeah, he's maybe a good person to talk to also.
Okay.
So you have about 5 names.
Yes, 5 names. Thank you very much. It's great to meet you. Thank you for your time.
Thank you for waiting. Thank you.
Okay.
Hope to meet you sometime in person.
Yes, that's what we do. We want to do.
Okay.
All
right. Please remain safe and well. Thank you.
Okay. Thank you.
Bye.
Bye.